everyone, I'd like to introduce our project Speech Emotion Recognition. Recognizing emotion through speech has been a relatively new field with various applications, ranging from recognizing improved and adaptive networks in the human world to simulating realistic avatar interactions in the virtual world.
Moving to our project flow, in our project we are extracting features of speech samples extracted from our data set, and the feature that we are extracting is MFCC. These features are then classified into different emotion classes using an SVM classifier. We are using an SVM classifier over other classifiers because the performance is much better over the others. After that, random test samples are given to the SVM trained classifier and to gain the output emotion class.
MFCC, that is, Bell Frequency Spectrum Coefficient, is a function that depicts the human ear. In sound processing, it is a representation of the power spectrum of sound. MFCCs of an audio clip is obtained as shown in the flowchart. The analog time domain speech is converted into a frequency domain digital signal after performing processes like FFT, that is the fast Fourier transform, and DCT, that is the discrete cosine transform. These processes are done to obtain the coefficients of the Bell frequency.
Support vector machine, that is the SVM classification. It is a supervised learning algorithm. It is used for regression or classification, mainly classification. It is a binary kind of classification method. In linear separation, here we have two classes, the stars and the circles. Here to distinguish these two classes properly, the hyperplane B is drawn. In case of non-linear classification, suppose this is our input. What SVM does is, it converts the data into a higher dimension, suppose squaring it. Now a fine hyperplane can be drawn between these two classes since they have been separated very distinctly. This is how the SVM binary classification works.
SVM is a binary classifier. Multi-class classification is difficult using SVM. An ECOC model reduces the problem of multi-class classification to a set of binary classifiers. Suppose that there are three classes, the coding design is 1 versus 1 and the decoding scheme uses a large G parameter. An 1 versus 1 coding model is designed as follows. As you can see from the table, the learner 1 trains on observations of class 1 and class 2. It treats class 1 as the positive class and class 2 as the negative class. The other learners are trained in a similar manner. This is how an ECOC model is built. We have implemented our project on MATLAB platform. I will explain in short the code of our project. AUDIR is a variable which contains the training speech data. Test variable contains the testing speech data. Now we need to extract the MFCC features of both the testing data and the training data. It is done using the MGC feature extract function. Thus, a dataset containing MFCC values is created and defined as a variable large for the training data and variable test1 for the testing data. Moving on to the classification algorithm, we have used the FITC ECOC function which defines the ECOC model. For this model, the variable t is the template SVM model. The SVM model is determined from the parameters of box constraint and kernel scale. Box constraint is the amount of permissible misclassification, whereas the values of kernel scale determines the generalization capability of the network.
Is a program for a small data set. In this, the training set consists of 42 files and the test set consists of 6 files. Now I am playing the fourth file of the test set.
Dogs are sitting by the door.
As you can hear, this sample has an angry emotion. Now let's see whether our algorithm predicts it accurately. As you can see, the fourth output file is classified as class 4. And class 4 is an audio angry class. Thus, the test sample is accurately classified.
Results. When we consider a small training set consisting of 42 sample files of 6 different emotions and 6 test samples of each type of emotion, we get 100% accuracy in the output. That is, all classes of emotions are correctly recognized. Now when we consider our training set to be 712 files with 8 test files, we get our accuracy as 75%. The reason for this is because we have considered only one speech feature, which is MFCC. If we consider other feature factors like format, pitch, energy, etc., we would get a better output. Also, when we tried real-time emotion recognition, the output accuracy was very low. This is because our accent of speech is very different from the accent of the actors that we have considered in our data set. All these factors need to be considered while recognizing emotions through speech. Thank you so much.